Have you ever really stopped to think about it? How does this box of circuits and silicon on your desk manage to hold on to a lifetime of memories? Well, in this explainer, we're going to pull back the curtain on the incredible engineering that makes it all possible. I mean, it really does feel like magic, right? This inanimate object holds our most precious photos, our most important work, heck, our entire digital identity. But, it's not magic. It's just some seriously clever engineering. Just think about it for a second. Your computer remembers photos you took years, even a decade ago, keeping those moments perfectly preserved. And at the same time, it remembers the password you just typed in. It's handling both the long-lost memories and what's happening right now. But here's the real head-scratcher. How does it remember all that stuff even after you shut it down and unplug it? I mean, where does all that information go? Well, to figure that out, we have to start at the very beginning, with the secret language that all computers speak. So, if we want to understand how a computer remembers, we first have to get a handle on its language. And here's the crazy part. It's an incredibly simple language, but it's powerful enough to build our entire digital world. Okay, so get this. Deep down at the absolute core of it all, every single piece of data, every photo, every song, every word, it all gets boiled down into what's called binary code. It's just a system using two symbols, a 0 and a 1. That's it. Each 0 or 1 is called a bit, and you could just think of it like a tiny light switch. It's either on or it's off. The real magic is how these simple little bits build on each other. You take a group of 8 bits and bam, you got a byte. That's enough to represent something like a single letter of the alphabet. From there, we just start scaling up to the words you already know, right? Kilobytes, megabytes, gigabytes, and terabytes. And each step up is roughly 1,000 times bigger than the one before it. Now, here's a little geeky detail for you. You hear kilo and you think 1,000, right? Makes sense. But in the world of computers, things are a little different because they think in powers of 2. So a kilobyte isn't exactly 1,000 bytes. It's actually 1,024. That's 2 to the power of 10. It's this cool mathematical precision that everything in our digital lives is built on top of. All right, so now we know our data is just a bajillion ones and zeros. But where does the computer actually put all of them? Well, it turns out your computer has two very different kinds of memory, almost like our own brains have short-term and long-term memory. First up, you've got RAM, which stands for Random Access Memory. Think of this as your computer's working space, its short-term memory. It's lightning fast, which is great for juggling apps, but, and this is a big but, it's volatile. The second you cut the power, poof, everything in it is gone. Then, on the other side, you've got storage. This is the computer's archive, its long-term memory. It's slower, for sure, but it's non-volatile. It holds on to your files even when the power's off. And that is the answer to our big question from the beginning. So let's dig into that long-term storage. How does it actually work? We've got to start with the OG, the classic workhorse, the traditional hard disk drive, or HDD. For decades, this thing was the backbone of our digital lives. And the best way to picture what it does? It's kind of like writing with magnetized ink on a microscopic record. Seriously, it's like a tiny, super fast record player, but instead of music, it's writing your data. So what's happening inside that little box? You've got these platters coated in a magnetic material, spinning at insane speeds. We're talking thousands of revolutions per minute. And then there's this tiny little arm with a read/write head that floats just nanometers above the surface. To give you some perspective, that's like flying a jumbo jet just a few inches off the ground and never ever touching it. This head then creates a magnetic field to flip tiny spots on that platter to represent our ones and zeros. It is an absolutely mind-blowing feat of engineering. But, moving parts have their limits. They're noisy, they use a lot of power, and, well, they can break. So the industry needed something new. And that led to a completely different approach, a kind of silent revolution in how we store our data. Enter the solid-state drive, or SSD. Its defining feature? No moving parts. No spinning disks, no flying heads. It's all electronic. And that changes everything. So how on earth do you store data with no moving parts? Well, SSDs use what's called flash memory. Just picture a massive, massive grid of microscopic traps for electrons. To write a 1, a tiny jolt of electricity pushes some electrons into one of these traps, and they get stuck there. To write a 0, the drop is just left empty. Since the electrons are physically trapped, the data stays put, even when the power is off. We're talking about storage at an almost atomic level here. This is why your computer boots up in seconds. So we've gone from spinning magnets to trapping electrons. The journey has been pretty incredible. But here's the thing. We are creating data at a rate that is just staggering. It's going to overwhelm even our best technology pretty soon. So where do we go from here? Well, scientists are now looking at the most efficient, most dense information storage system ever known, life itself. Check out this number, 175 zettabytes. That's how much data we're expected to have globally by 2025. Now, a zettabyte is 1,000,000,000,000 gigabytes. It's a number so big it's hard to even wrap your head around it. Let's try. If every gigabyte was a single brick, 175 zettabytes would be enough to build the Great Wall of China more than 200 times over. So yeah, we're gonna need a much, much denser way to store all this stuff. And that brings us to DNA data storage. This is straight out of science fiction, but it's real. The basic idea is to translate the computer's binary code into the four-letter genetic code of life, ACGNT. You could assign, say, A to be 00, C to be 01, and so on. We could literally encode a movie or a library of books into a custom-made molecule of DNA. And the amount of data you could pack in is just unbelievable. This quote really says it all. You could store the entire digital history of humanity, every website, every photo, every single thing, in something the size of a small van. Not only that, but it would be incredibly stable and could last for thousands of years. And this all leads to a pretty profound final thought. You know, for most of human history, our story has been defined by what we managed to save, what didn't get lost to time. But as we move from storing data on matter to storing it in the very structure of life itself, we're heading into an age of almost infinite, permanent storage. So the question isn't what can we save anymore? The new question is, what will we choose to remember forever?